Hello guys, in this lecture we will study the relationship between Kc and Kp. You are already familiar with this term Kc, which we denoted as equilibrium constant. Now when we were using the term Kc, we were denoting equilibrium constant in terms of concentration. When Kc was used, we were denoting equilibrium constant in terms of concentration. But when we are using Kp, please remember this, equilibrium constant can also be denoted in terms of pressure also. Okay, in terms of pressure also we can denote equilibrium constant. But the question arises, how or why we can consider that equilibrium constant can be denoted in the form of pressure also apart from concentration. Because you must be knowing one formula, PV is equal to nRT. That means pressure into volume is directly proportional to the number of moles also. Number of concentration, number of moles means concentration also. So pressure is directly proportional to, pressure into volume is directly proportional to concentration. That's why since we know this PV is equal to nRT, that's why we can denote equilibrium constant in the form of pressure also apart from concentration. First thing first, we will write down one reaction. AA plus BB will give, this will give CC plus DD. We are already familiar with this reaction. Now guys, you already know, if I tell you to convert this equation into equilibrium constant, that you can easily do. But now we will convert this equation in the form of Kp, that means in the form of pressure. So how we can write this? Pressure of capital C, sorry, just a minute. Pressure of capital C raised to the power small c, pressure of capital D raised to the power small d, upon pressure of A raised to the power small a, and pressure of B raised to the power small b. This is how you can write expression for Kp, equilibrium constant, in the form of pressure. This is how it is written. Pc raised to the power C, Pd raised to the power small d, Pa raised to the power small a, and Pb raised to the power small b. So the only difference between Kc and Kp you can find out here is that we are denoting concentration now in the form of pressure. So earlier we were using C raised to the power C, D raised to the power D, A raised to the power A, and B raised to the power B. Now in front of that, a small p will come, which will denote the pressure condition. Now please listen carefully. Also we know that PV is equal to nRT, pressure into volume, is equal to number of moles or concentration. So we can write this as P is equal to N upon V into RT, which we are taking as ideal gas and pressure situation. Ideal pressure situation. Now guys, we know that this N represents concentration. Okay, this N represents concentration, and N by V represents concentration, and simply N represents number of moles. So if you divide number of moles by volume, you will get concentration. So I can change this equation now, and I can write, instead of P is equal to N by V by RT, N by V into RT, I can use the word here as concentration. In short, I am writing down CONC, concentration into RT. Concentration into RT. So now as you can see, we have got this, that pressure can be denoted as concentration into RT. Okay. Now we can use this. We can use this equation 2 and can merge it into equation number 1. So from here you will see we will get Kp is equal to concentration of C RT, concentration of C RT raised to the power small c, concentration of D RT into raised to the power small d. Similarly, concentration of A RT raised to the power small a and concentration of B RT raised to the power small b. Now friends, I can also write this expression as Kp is equal to, can I write like this? Concentration of C raised to the power C, concentration of D raised to the power small d, concentration of A raised to the power small a, and concentration of B raised to the power small b. I have taken this on one side. Now there was RT, RT and C and D. So can I write this as RT raised to the power C plus D, small c plus small d, and RT raised to the power small a plus small b. Can I write this expression as this also? Yes, we can write this. Now guys, you know that if you look here, what is this? C raised to the power C, D raised to the power D upon A raised to the power A and B raised to the power B. We know that this is Kc, equilibrium constant in concentration. Okay, this is Kc. So this expression I am writing down as Kc, and I am taking RT raised to the power C plus D minus A plus B. And we know that C plus D, they are number of moles of product, and A plus B are number of moles of reactants. Now in short I can write this expression. In short I can write this expression also as Kp is equal to Kc RT, and this number of moles of product minus number of moles of reactant, simply I can denote as delta N. Delta N will denote change in number of moles. Delta N here is denoting change in number of moles. So this is the relationship between Kc and Kp in equilibrium constant. You can denote equilibrium constant in the form of concentration also and in the form of pressure also. Now guys, one final rule you have to remember, that below this N you have to take a small g, and this small g denotes that you have to take number of moles of gases only. In equilibrium constant in pressure, you have to take number of moles of gases only. You have to avoid taking number of moles of solids as well as liquids. This was our rule that earlier we just studied in the Kc, that pure solids and pure liquids were ignored. Similarly, in Kp also, this delta N, change in number of moles, below it we are writing small g, which represents that only change of number of moles of gases are considered. We have to ignore the solid moles as well as the liquid moles. Okay, moles which are there in the solid and moles which are there in the liquids, we have to ignore this. We have to take only the moles of the gases only. Okay, so guys, don't get confused. This delta N, okay, this delta n simply means you are subtracting number of moles of product with number of moles of reactants. Okay, this is delta n, and below delta n we are just writing small g in order to denote that number of moles will only be taken of gases. We have to ignore number of moles of solids and number of moles of liquids. Please remember this. Okay, I hope you have understood till here everything. Thank you very much.